part 3 of the lecture series on nutrition labeling compliance. And so what we've done is walk through some of the different requirements that the Canadian Food Inspection Agency has had set up for Canadian food manufacturers to identify what their error tolerances are for nutrition facts tables. And so at the end of this lecture, we're going to be able to calculate the error variance allowable on a nutrition facts table for a typical food product and identify the correct sampling criterion and classification for that product. And for those of you who want to follow along on the internet, I am going to recommend that you look up the nutrition labeling compliance test at the Canadian Food Inspection Agency. I realize from my video you might not be able to cut and paste this web page, but again, this video is current as of spring 2020, and I always highly recommend that people go back to the Canadian Food Inspection Agency website to make sure that you've got the most up-to-date information for any sort of regulatory scenario. So just a quick screen grab. We have a couple different classifications of products. We talked about this in our previous video. Class 1 products, these are the products that have added nutrients. So if you're fortifying a food product, adding something like vitamin C or folate or iron or niacin, if you have either mandatory or voluntary fortification, you have different acceptance criterion. So in the case of this acceptance criterion, for the subsample, you can only have a greater than or equals to 50% of the declared nutrient value in the subsample, and within the pooled criterion to tolerance, you can only have greater than or equal to the declared nutrient value. And there has to be this 99% confidence interval, and there's additional notes for this. I'm going to spend most of our time on the class 2 criterion here, but what you need to make sure is that you are 99% confident on this within a normal distribution. And this is a more advanced topic than first year college class, but Class 2 and Class 2 Min and Class 2 Max criterion, sorry, the fun of recording at home is that people randomly walk in on you. Class 2, this is where you have a front of label claim. So it's naturally occurring. You haven't added it intentionally. It's there from the natural ingredients, and you're making a front of label claim. So in this case, there are some nutrients where you want those nutrients, and so these are min statements. So each subsample has to be greater than or equal to 50% of the declared nutrient value, and it has to be greater than or equal to 80% of the declared nutrient value in the pooled sample. And so these are things like protein, omega-3s, and so on. The positive, good for you nutrients are in this must be greater than 50% of the declared nutrient value in your nutrition facts table. And you may be just mortified to think of that scenario, but again, this accounts for lot to lot variation on the inputs for making this product. And then we've got Class 2 Max. So these are nutrients that we don't want to exceed in our nutrient facts table. So things like trans fats, sodium, sugar, cholesterol. This is where it has to be less than or equal to 150% of the declared nutrient value in single subsamples, and it has to be less than or equal to 120% of the declared nutrient value in the pooled sample. So what on earth does this mean? Let's walk through an example. So the fun of recording videos at home, I went and raided my pantry, and just as a good example, I found this lovely fast and fancy Chinese fried rice from Uncle Ben's, which is owned by Mars FM Foods, and it has a front of label claim. So on a per 42 grams prepared, it has 42 milligrams of sodium, or 18% of the daily value. And so because of this front of label claim, we can go through and do the compliance test. So let's walk through what do we know. So we've got 420 milligrams sodium per 42 gram serving, you'd think that perhaps this was intentional because these numbers are so uncanny. That's 1,000 milligrams sodium per 100 grams serving. This is a class 2 front of label claim. It's a max claim because we want less of this nutrient. And so that criterion 1, all samples must be less than or equal to 150% of the value declared, and the criterion 2, so the pooled sample must be less than or equal to 120% of the value declared. So as I mentioned in the previous videos, that when the CFIA is doing the sampling program, they'll take a minimum of 12 of the consumer packages. So they would have gone to the store or gone to the manufacturer and pulled 12 of the packages from a unique lot, and then they would pool from that 12 into a group of 4 packages, pooled together into 3 subgroups. And then they'd send it out for analytical testing to make sure that it's compliant. So again, where does this go? Well, we have to also think about the rounding rules on these values. And from the web page, pardon me, I'm going to escape out here and I'm going to jump to the web page. So this is the nutrition labeling compliance. That here is the statistical framework where they go through and they do all the different error variants and consumer risks. I'm going to leave that because, again, this is a first-year college class, and I know that the students haven't taken statistics at this point, and so doing the lot variability and all of the compliance on this is a little bit beyond the scope of the course. We have to remember that on every nutrition facts table, there's rounding information. And so we need to know what the rounding value is so that we can think about what the actual maximum value could be. So this is linked out. It's called Appendix 3, the rounding of nutrition facts table information. If you've been designing labels in ESHA, we know that the rounding is already accounted for by the software, and it's gone through and taken all of these wonderful values. So each of the different elements of the nutrition facts table can have a rounding component. So in the case of calories, if it's less than 5 calories, you can round it to 0. If it's greater than 50 calories, it can be in multiples of 10, and so on. All of these rounding rules are really quite interesting to think about when it comes to the different serving sizes and the different opportunities that you can massage things within the product development. So let's find sodium in here. Pardon me. Sodium. So in the case of sodium, if it's less than 5 milligrams and meat's free of sodium, you can put 0. If it's less than 5 milligrams, all other cases, you put it to the multiple of 1 milligram. And if it's between 5 and 140, it's rounded to the nearest 5. And if it's greater than 140 milligrams sodium, then it's rounded to the nearest multiple of 10. And just to note, this column here, the far right column, that is how are you expressing percent daily value, and in this case it's the nearest multiple of 1. So that's worth noting. Let's go back to the PowerPoint here. So checking Appendix 3, based off of our rules, it has to be the nearest multiple of 10. And because we're doing a max, it means that we need to know what is the maximum number that's going to round to that nearest multiple. We have to be thinking a little bit of reverse engineering here. So all the numbers inclusive between 415, 16, 17, all the way to 424, all fit into that nearest multiple of 10 rounding to 420. So in this case, our max value is 424. That's worth pulling forward to the next calculation. So we have a max pre-rounding value. 424 milligrams is the max that's going to round in the tens value to 420 milligrams. So under criterion 1, based off the calculations that are required, we have to find the max pre-rounding value, and then we multiply that value by the 50%. It's not this is what's going to help us define this, because again, we have to consider that that rounding could be adding to the number. We talked about that in the second video, that rounding throws things off quite a bit in many different labels, and those rounding issues can become problematic, and so we have to take that into account. So criterion number 1, 424 milligrams plus 50% of the declared value. So 50% 0.5 times 420 plus 424 equals 634 milligrams. That is our criterion 1 sampling limit. So no single sample can be above this limit in that pooled group of 12. Criterion 2 max limit is going to be that as same max pooled value, 424 milligrams, plus the 20% times the declared value. So 20% times 420, add that together, and we have 508 milligrams per 42 grams. The pooled sample cannot be above this limit. So when we've pooled those samples, that 12 into 4 and then that 4 into the average value cannot be above 508. So let's imagine we're the CFIA, or maybe we're doing our own internal testing to check compliance, and we send out and get some values. So let's say we sent out, and well, by the time they're pooling this value, they're not going out and sending you back a report on a per 42 gram basis. They're going to send it back to you on a per 100 gram basis. And let's say these are the values we got back. We have to figure out what is the appropriate multiplier to get it back to that per serving basis. So if we divide 100 by 42, we're going to get 2.38. And if we divide this value by 2.38, we're going to get 441 milligrams per 42 grams, and vice versa, all the way down. So, hey, check it out. You'd be surprised. Perhaps I made these numbers specifically to fit the mold. But let's remember, too, what were those criterion for cutoff? I am sure that Uncle Ben's and the folks at Mars Foods and FM Foods are absolutely 100% focused on compliance, and I am very confident that they're a company that is very established in terms of making sure that regulatory compliance is intact. But let's think about those criterion. So, in theory, that pooled value could be up as high as 508 milligrams per 42. And criterion 1, any single sample to make that average could be upwards of 634 milligrams per 42 grams. So think about this. If you were, Uncle Ben's is a great company and they're very compliant, but let's say you're not Uncle Ben's, maybe you're Uncle Neb's, the knockoff rice company, and you're creating a flavor profile because of sodium. Because of this compliance rule, you can push the limit on your sodium and still have a front of label declaration that is completely different. And should you do this? No. Do companies do this? Maybe. Should you do this? No. You should be focused on compliance, and you should be focusing on making sure that your product is well within compliance. But have I had companies come to me in confidence and say, hey, are we allowed to do this? These are the compliance rules. And the compliance rules are extremely generous in this case, that we have that plus or minus 20% error variance that's permissible on this type of claim. So think about that. Think about that. You can be pushing it upwards of 20% higher and still be compliant within these requirements. So good job on the calculation. I'm going to recommend that you walk through try the calculation out on your own to see that you can walk through and do example calculations of this sort. Thank you very much, and we'll talk to you soon.